Welcome to the deep dive. Today, we're diving into the world of low light image enhancement.
LEA?
LAE, yeah. And this really cool research paper called ReLLIE, Deep Reinforcement Learning for Customized Low Light Image Enhancement.
Nice.
Yeah. You know those photos, you take them, it's kind of dark, maybe grainy, everything's, it's kind of blah.
Yeah.
ReLLIE's trying to fix that.
Yeah, it's tackling two big problems with LOE.
Okay.
First, low light is low light, but it's not all the same, right? Like candlelight at dinner,
Yeah.
totally different than like a street at night,
Oh, yeah, for sure.
Need different enhancements for each.
Yeah.
And the second problem, what you think looks good might be totally different than what I like.
Yeah.
Some people, they want those super bright photos.
Yeah.
Others, they want that kind of moody look.
Right.
So figure one in the paper, it shows this the same photo enhanced like a bunch of different ways.
Oh, cool.
Yes, you can like really see it.
So one size fits all doesn't really work here.
Nope, not at all.
Okay, so the paper talks about the one-to-one method. What's that?
It's like think of it like those old photo filters, right?
Okay.
Get your image, you slap on a filter, and boom, that's it, one output.
Yeah.
But like we said, low light, it's not that simple.
Right, and people like different things.
Exactly.
So how does it get around that?
It uses deep reinforcement learning, DRL.
DRL.
Think of it like an agent, right? And it's learning to make decisions in an environment to get the best reward.
Okay.
Kind of like a video game.
Right.
So here, the agent, it's a neural network, and it's learning how to adjust the light, like pixel by pixel in the image.
Wow.
And the reward, that's how good the image looks, based on like certain rules.
Nice. So basically playing a game, trying to enhance the best way possible.
Yeah, pretty much.
But it's not just making it brighter everywhere, right? The paper talks about these light enhancement curves, LECs.
Yeah, LECs are cool. They're like little curves, and they adjust the brightness for different parts of the picture.
Oh.
Figure 3 shows them. You can see how it works.
Okay.
And by doing these LECs like over and over, ReLLIE can get some really detailed enhancements, brightening some spots, leaving others alone, and it keeps the details and avoids those weird colors you get with some other methods.
Right. That's really cool. So how does it know if it's doing a good job? Does it need like a perfect picture to compare to?
That's the thing. It doesn't. That's what's so awesome about it.
Really?
It doesn't need those like perfectly matched pairs of low light and good light.
So it can learn without a cheat sheet.
Yeah, exactly.
How does it even do that?
It uses non-reference losses. Basically, it looks for things that make an image look good.
Okay.
Like the lighting is consistent between different areas, if the exposure is good, balanced, and if the colors look realistic.
So it knows what looks good without having to compare directly to another picture.
Yep, that's right.
Wow. The paper talks about 4 of these non-reference losses, right? What are they trying to do, like, specifically?
Okay, well, think about a picture of a wall, right?
Yeah.
You'd expect the lighting to be, like, pretty much the same all over it.
Unless there's, a lamp or something.
Yeah, right, exactly. So that's what spatial consistency loss does.
Okay.
Make sure that even when brightening up a dark image, ReLLIE keeps it looking natural, no weird patches of light.
Oh, that makes sense.
And then there's exposure control loss. That makes sure the image isn't too dark or too bright.
Like finding the right exposure like a photographer would.
Yeah, basically. So it's well lit, but not like blown out.
Right.
Okay, and then there's
2 more.
2 more, yeah. Illumination smoothness loss that makes sure there's no like really harsh fake looking transitions between the light and dark areas, You wouldn't want in a picture that looks like someone just shined a spotlight on one section, right?
No, that would look weird.
Totally. And then last one, this one's new, the ReLLIE team made it. It's called channel ratio constancy loss, or CRL.
Okay.
It's all about color.
So that's how ReLLIE keeps the colors from getting all messed up.
Exactly. You know how sometimes when you just crank up the brightness in, like a photo editor?
Oh, yeah.
The colors get all weird, things get washed out, or they get a weird tint.
Yeah, I hate that.
Well, CRL stops that from happening. It looks at the ratios between red, green, and blue in the original.
Okay.
And it tries to keep them the same while it's enhancing the picture. It's like a built-in color expert.
Wow, so all those losses work together and it doesn't need that perfect comparison picture. That's incredible.
Yeah, it's really cool.
So we talked about the agent and the reward, but you mentioned ReLLIE does something else special for color too, right?
Oh, you mean the channel-dependent momentum update?
Yeah, that.
CDMU? Yeah, it's It's kind of a mouthful, but basically, it makes sure that when you change one color, it doesn't mess up the others. Like, if you make the red brighter, but you don't think about the green and blue, you can get some weird color shifts.
Like those pictures where everything's too pink or too yellow?
Yeah, exactly. CDMU stops that, makes sure the colors all work together.
So it's like built-in color balancing? That's amazing.
Yeah.
Okay, but what about noise? Like a lot of low-light pictures, they're noisy too.
Right, well, ReLLIE's flexible, so it can handle that.
Okay.
The main algorithm, it's for the light enhancement, but there's an optional noise reduction step you can add.
Oh, cool. So it's modular.
Exactly.
Mm.
You can use almost any noise reduction tool out there.
Okay.
The paper mentions FFDNet, but you could use others too.
So you got this powerful base for low light, and then you can add noise reduction or other stuff on top.
Yep, exactly.
Awesome. Okay, but how does it do in the real world? Does it actually work?
It totally does. They tested it in a, get this, a zero-shot scenario.
Zero shot.
Imagine you're teaching someone to enhance pictures, right?
Okay.
But you can only show them one example.
Oh, wow.
That's basically what zero-shot learning is.
That's tough.
It is. But ReLLIE did great, even with just one example. They compared it to other, like, top methods, used a standard set of low-light images.
Okay.
And ReLLIE was consistently better.
So it's not just theory, it actually delivers.
Yeah, it's the real deal.
You mentioned earlier, users have some control over the enhancement, right? How does that work?
That's where it gets really cool. Remember those LECs, how they can be applied multiple times?
Yeah.
Well, users can choose how many times those are applied.
Oh, so I can make it, like, more or less intense.
Exactly. Figure 8 in the paper shows how the image changes with each step.
Cool.
It starts subtle, and it gets more dramatic each time.
That's awesome. That kind of control is pretty rare, isn't it?
Yeah, it is.
Okay, so, but the real test, do people actually like the way ReLLIE enhances pictures?
They did a user study. People compared images enhanced by ReLLIE to those from other methods.
Okay.
And guess what? They consistently preferred ReLLIE's images, so they look more natural and just, better overall.
So it scores high on the technical stuff and people like how it looks.
Exactly.
That's amazing. Did they do any other tests, like to see how each part of ReLLIE affects the final result?
They did what are called ablation studies, where they basically took out different parts to see what happened.
Oh, interesting. Like see what's really essential.
Yeah, exactly. And get this, every single part of ReLLIE, all those loss functions, the CDMU, even the noise reduction, they all matter.
Wow.
Like if you take away even one, the image quality goes down.
So it all works together perfectly.
Yep, it's like a perfectly tuned machine.
That's awesome.
Yeah, it really shows how clever the researchers were, how powerful deep learning can be. But, now that we've gotten into all the technical details, I think it's important to think about the bigger picture too.
Okay, yeah, let's zoom out a little. What are you thinking?
Well, one thing that strikes me is ReLLIE could really change who has access to good image enhancement.
Okay.
For a long time, only professionals have the tools to do this stuff.
Right, and those tools are usually expensive and complicated.
Exactly.
Yeah.
But with ReLLIE, it's like we're making those tools available to everybody.
Yeah.
Imagine anyone, no matter their skill level,
Yeah.
could take a dark photo and make it something amazing.
That would be incredible.
It's like giving everyone a dark room in their pocket.
Yeah.
And as AI gets better, we'll probably see even more tools like this.
That's so cool. But do you think there are any, ethical things to think about with these tools getting more powerful?
Yeah, for sure.
Sure.
Like we talked about before, you can use these tools to make pictures that aren't really accurate.
Great.
So we have to be careful. Think about how they could be misused.
It's like any powerful tool. It can be used for good or bad.
Exactly. Being open and honest about how these technologies work, that's super important.
Totally agree.
The more people understand, the better they can use them responsibly.
Okay, so we talked about how ReLLIE works, how cool it is, and also how we need to be careful with it.
Yeah.
Where to go from here? What are your final thoughts before we move on?
As we've been talking, I keep thinking about how ReLLIE is actually learning. It's using deep reinforcement learning to figure out how to make pictures better based on those loss functions, which are basically telling it what we think looks good.
Right.
So we're basically teaching machines to see the world like we do.
Wow.
And that makes me wonder, what if machines start developing their own sense of what looks good?
Whoa.
What if they make images that we like, even if they don't fit our usual ideas of beauty?
That's kind of scary, but also really cool. It's like the machines becoming artists themselves.
Exactly. And then we have to ask, what does it mean to be creative? What's the role of technology in art?
Yeah.
And how will our ideas of beauty change? as machines become more involved in art.
It's a lot to think about.
It is, but that's what makes this whole field so exciting. We're at the beginning of something huge, and it's up to us to make sure it goes in the right direction.
Well said. So everyone listening, keep exploring, keep learning, and keep imagining. Image enhancement is changing so fast, and there's so much potential.
Yeah, and who knows, maybe one of you will be the one to create the next big thing that changes how we see the world.
That's a great thought. Thanks so much for taking us on this deep dive into ReLLIE and customized image enhancement.
My pleasure.
And to all our listeners, check out the show notes for a link to the full research paper if you want to learn even more. Until next time, keep those creative sparks flying.
You know, as we kind of move into this next part of our deep dive, I keep thinking back to those ablation studies we talked about.
Yeah.
They really show how important each part of ReLLIE is.
Yeah, I'm really curious about those. What did they, find out?
Okay, so remember those 4 non-reference losses, right?
Yeah.
Spatial consistency, exposure control, illumination smoothness.
Yeah.
And then the new one, channel ratio constancy loss.
Mm-hmm.
Well, they wanted to see what happened if they, took each one out.
Ah, so, what's really important?
Yeah, exactly. Like if you're making a cake and you take out the sugar,
Oh, right.
what happens? So they started with ReLLIE, but without any of the losses.
Oh,
And the results were not great.
I can imagine.
Yeah, it was bad. Like some images were way too bright, others super dark. Lots of weird colors, details were blurry, just a mess.
So those losses are doing a lot of work to make those good images we saw.
Yeah, for sure.
So what happened when they started adding the losses back in?
So first they added back spatial consistency loss. Remember, that's the one that makes the lighting look even across an area.
Yeah, like the wall example.
Exactly. And right away, the images were so much better.
Really? Just from that one?
Oh yeah, huge difference. No more blotchiness. Everything looked way more natural.
Oh, okay.
Then they added exposure control loss, and boom, the brightness was perfect. Not too dark, not too bright.
Ah, so it found that sweet spot.
Yeah, just so you could see all the details.
Makes sense.
And then illumination smoothness that got rid of those, harsh lines between light and dark, made everything look more realistic and nice.
Okay, so those 3 are all about making the image look natural, basically.
Yeah, pretty much.
But what about that 4th loss? The one they made?
The channel ratio constancy loss,
Mm.
the CRL. Oh, that one was huge for color.
Oh, okay.
Without it, the colors were all messed up. Some were pink, some yellow, some just washed out.
That's the worst.
Yeah, especially if you want your photo to have a certain mood. Color's super important.
For sure.
CRL fixed all that. The colors were balanced. The images looked amazing.
Wow, so it's like all these losses work together to get the best image?
Exactly. Each one does its part.
That's so cool.
It really shows how smart these algorithms can be when you train them, right?
Okay, so we talked about the losses. What about that CDMU thing? What happened when they took that out?
Ah, yeah, the channel-dependent momentum update. Basically, it ensures that when you change one color, you don't mess up the others.
Right.
It prevents, weird color shifts and halos.
Yeah.
Think of it like the conductor of an orchestra, making sure everyone plays together nicely.
Oh, I get it.
Yeah, so
Yeah.
without CDMU, the colors were all uneven and blotchy, didn't look natural at all.
Okay, so it's all about balance.
Yeah, exactly. All these different parts of ReLLIE working together.
It's amazing how complex it is.
It is, but that's what makes it so cool, right? They really created something special.
They did. Okay, but before we move on, what about the noise reduction? What did they find out about that?
Oh yeah, the noise reduction, that's like the finishing touch.
Okay.
It makes the images even better, especially if they were taken in, really low light where there's a lot of noise.
Right, because even if you brighten the image, the noise can still be there.
Exactly. So the noise reduction smooths everything out, brings out the details.
Like cleaning a painting so you can see it better.
Yeah, perfect analogy. So yeah, the ablation studies show that all the parts of ReLLIE are important. They all work together to make those amazing results.
It really is like a perfectly tuned machine.
It is. Okay, so now that we've looked at how ReLLIE works, I think it's time to talk about what it means, in the bigger picture.
Yeah, totally. What are you thinking?
Well, I think ReLLIE could really change how people use image enhancement.
How so? Okay, so we've explored how ReLLIE works, how cool it is, and also how we need to be careful with it. What are your thoughts about the future of all this?
Yeah, one thing I'm really excited about with ReLLIE is how it could change who can use good image enhancement.
Okay.
For a long time, it was just professionals. They had the tools, the expensive software.
Yeah, all that complicated stuff.
Exactly. But ReLLIE, it's making those tools available to, Everyone.
That's really cool.
Imagine anyone, no matter what they know about photography, they could take a picture, enhance it, make it look exactly how they want.
That's a really cool idea, giving everyone those tools to express themselves, creatively.
Yeah, like everyone gets a darkroom right in their pocket.
I like that. And AI is just going to keep getting better too, right?
Oh, absolutely. We're only going to see more tools like this.
It's exciting, but do you think there are any, ethical things to consider? These tools are getting so powerful.
Yeah, that's a good point. We talked about how these tools can be used to make images that aren't really real.
Right.
So we got to be careful. We got to think about how they could be misused.
It's like any powerful tool, it can be used in the wrong way.
Exactly. We need to be open about how this stuff works, teach people about it.
Yeah, totally.
More people understand, the better they can use it the right way.
Okay, so we've talked about how ReLLIE works, how amazing it is, and also how we got to be careful with it. Any final thoughts as we wrap up?
It's funny. We've been talking about all these possibilities, and I keep coming back to the fact that ReLLIE is, well, it's learning.
Yeah.
It's using that deep reinforcement learning to figure out how to make images better based on all those rules we talked about, the ones that tell it what we think looks good.
Right, right.
It's like we're teaching machines to see the world, like through our eyes.
Wow, that's deep.
And it makes me wonder, what if machines develop their own sense of what's beautiful? What if they start making pictures that we like, but they're not what we normally consider, good?
Whoa, that's kind of trippy. It's like the machines become artists.
Exactly.
Yeah.
It makes you think, what does it mean to be creative? What's technology's role in art?
Yeah.
And how will our ideas of beauty change as machines, become more involved?
That's a lot to think about.
Yeah, it is. But that's what makes this feel so exciting, right? We're on the edge of something huge, something new, and we get to shape it.
Well said. So, to everyone listening, keep exploring, keep learning, and keep using your imagination. Image enhancement is changing so fast, and the possibilities are endless.
You got it. And hey, who knows?
Mm.
Maybe one of you will be the one to create the next big thing, the next ReLLIE, and change how we see the world.
That's a perfect way to end it. Thanks so much for taking us on this deep dive. It's been awesome.
It's been my pleasure.
And for everyone listening, be sure to check out the show notes for a link to the full research paper if you want to go even deeper. Until next time, keep those creative sparks flying.